Hello, I am Park Sangjun, who is developing AI voice dubbing services at Samsung Research. Today, I would like to introduce you to various voice models and some of our technology challenges. This is my content. Let me first talk about Samsung Research's voice and sound AI in general. Samsung Research has been developing voice and sound AI technology for a long time. Switching sound and voice and finding the speaker, differentiating the speaker. And with the sound AI, we can separate the source using source separation technology, and these technologies are applied on various Samsung products, mobile devices, and home appliances. Recently, Galaxy AI's interpreter and audio eraser were developed using this technology. And you can open the refrigerator just by saying open the refrigerator. Individual voice AI models can expand the functions and experience of devices. I'm sure that it's high time that we think about the next step. Using the various voice AI model, we can come up with more user-friendly that has biggest impact on our business. First is to combine various models. Recently, we have combined various voice AI models to develop the services. And for example, we can provide voice assistant technology, and they are being developed into services. And today, I want to talk about AI voice dubbing technology. And recently, global video platforms are coming out with so much global content. For example, as you're well aware, the Squid Game, K-pop Demon Hunters are blockbuster contents that are gaining popularity around the world. And YouTube subscriber, Mr. Beast has the largest number of subscribers, 440 million subscribers. Mr. Beast provides individually dubbed content. So global contents are gaining momentum around the world using the dubbing and subtext technology. And voice dubbing market will only grow down the road, and AI's portion is growing as well. AI voice dubbing technology compared to voice actor has a cost advantage, as you can see on the right-hand chart. Voice actor versus AI cost is very low. So it can be done at affordable cost, and we have to think about improving the quality of our technology. So I want to talk about SR voice dubbing technology that can improve the quality of voice dubbing. End-to-end voice dubbing pipeline, as you can see on the slide, combines various AI models from input video to dubbed video. It has end-to-end pipeline. And each AI model needs to function organically, seamlessly to minimize cost and human intervention. This flowchart shows function by function pipeline, and in fact, the model has to make arbitrary decisions from time to time. Like, in order to maintain background noise, it has to go through background noise separation. So the background needs to be separated from human voice, and then decide whether to dub the background noise or not. So by using various AI models in an intelligent manner, we have to come out with good logics. Each individual models once the performance declines, what kind of outcome are we going to experience? For scene segmentation, and the video will be broken down into scenes. And if that's not done properly, then we will see very large or small context. And when the scenes are combined again, there might be discontinuity. And individual models' performance is important, and overall end-to-end dubbing performance is also important. Today, I want to talk about speech generation, part of this table. When speech generation is flawed, it will create unnatural dubbing speech. And in order to improve this performance, we are focusing on two technical points. First, we try to have human-like natural voices with our dubbing technology. First, the background. When people talk, for background, there's the rich style speech or spontaneous style, as if we are talking in our everyday life. And read style speech will require accurate pronunciation, fixed and repetitive prosody. However, for spontaneous style, the focus would be on conveying thoughts and intents, would be more expressive, and there are certain expressions that like filler, stuttering, a lot of pause in spontaneous style of speech that will make the speech more natural. In order to model spontaneous style speech, we use two technology. First is architecture. In the past, there was very explicit alignment between text and speech. This will lead to accurate pronunciation, but would be less natural. So from given text, we want to do entire duration modeling and then generation of speech. And unlike the conditional way, we do global conditioning of text to come out with more natural voice. And for data, existing TTS use mostly read style data sets, but we try to use spontaneous style data sets as much as possible to achieve human-like naturalness. And then we are also focusing on voice cloning. So when we are dubbing, we are not just creating the voice, but we try to make it sound like the original voice of the speaker by using voice cloning technology. And the characteristics of human voice can be classified in spectral properties and temporal properties. Timbre, pitch would be spectral properties, and prosody, speaking rate, would be temporal properties, which would be more difficult to replicate with voice cloning technology. So we try to introduce in-context learning so that reference speech can be given as a context, and then to try to fill up the voice. And we can follow the reference speech by doing this. And data, there will be much more data. We are using hundreds of thousands of hours of data to express various properties of voice. Using this technology, we have created a voice cloning sample, and I will play this for you.
Forum 2025. Are you having a good time? I hope so, because we worked very hard to make this tremendous, really tremendous. Now, this is the last presentation. Don't worry, no more talking after this one, I promise. Just a little bit more energy and you'll make it.
Did it sound like the original speaker? So as I said, this is your last presentation. So I've shared this dubbing demo, but because of the copyright issue, I cannot show you the video, which is very regrettable. Apologies. If you're still interested in our dubbing technology, please let us know, and we would love to share more demo videos and look for collaboration opportunities. So instead of demonstration, we wanted to focus some of the pain points that we are trying to overcome. With dubbing, having a similar voice is important, but there is always trade-off. Accent is part of the speaker's identity. And for dubbing, we need to have cross-lingual voice cloning. And that leads us to decide the accent for dubbing. If the reference speech is in English and it's produced in Korean, what would be the most natural accent in Korean to make it sound like the original speaker? We have prepared 3 samples. The later you go, the similarity will be low, but it will sound more natural. In the first sample, similarity is rather high.
AI Forum 2025. 이제 제가 사실 트럼프 대통령인데요. 삼성 AI 포럼에서 만나뵙게.
I am President Trump, and it's an honor to meet you here at Samsung AI Forum. I'm President Trump. Nice to meet you here at Samsung AI Forum. The last sample sounds like any elderly man in your neighborhood. Sounds very natural and familiar, but sounds less like the original speaker. So we have to find the right trade balance, which achieves the best sweet spot for customer experience. Second point that we are trying to tackle is to decide what to dub and what to keep. Basically, we don't have to dub everything. Excessive dubbing would make it less natural. There are sounds that can never be dubbed, like background noise sound effects. We need to maintain original sound for that. And for non-verbal human sounds like laughter, coughs, these sounds can be generated as sound effects, but it's better to keep the original sound. Last but not least, singing vocals. We need to maintain the melody of the vocals, so after dubbing, it might sound unnatural. And songs, we need to keep on the original vibe. For songs we don't dub, we try to keep the songs intact. But other sounds, we try to dub. So for variety of sounds, we have to decide whether to dub or whether to keep. So we need source separation technology and decide how to process each models. Last but not least, this dubbing technology can be used for both B2B and B2C. For OTT partner app companies, when they want to globalize their contents or develop more accessible services, for example, for people with vision disabilities. And there are certain countries that legally require subtexts. And for individual users, video creators are gaining momentum these days, so they can expand their contents multilingual at a very low cost, and viewers will be able to enjoy their contents in their native language. These are some of the potential applications for our technology. So that's all for my presentation. Thank you very much for your attention.